Alright, so we started with this equation. I created my groups, pulled in my negative, right? So I want to make sure I know I have to pull out a negative GCF. So the factors between 12BC and 4BD that I can pull out as a GCF is 4B, right? Because I can pull out a 4 from each. I can pull out a 4 from 4. I can pull out a 4 from 12. I can pull out a B. I can pull out a B. I'm left with 3C minus D. Alright? Then looking at my second group, I have negative 15xc plus 5xd. I can pull out a negative 5, and I can pull out 1x. From both of those terms, I'm left with my 3c minus d. So I have my like terms, I have my coefficients. I pull out my like terms, I combine my coefficients. I'm left with 3c minus d times 4b minus 5x. Any questions on that one? Everybody good on copying the information if they need to? Alright. So, number 20, I was given 16mn minus 4m squared plus 28n minus 7m. And I did not have to reorder this or anything, so I went ahead and created my two groups. For my first group, I can pull out a 4m. I can pull out a 4 from 16, I can pull out a 4 from 4. Each term has at least one m. This one actually has two, but at least one that I can pull out. So I did so. In doing so, I'm left with 4n minus m. That's my GCF for my first term. My second term, the only thing I have in common are my numbers. So I can pull out a 7 from 28, and I can pull out a 7 from 7. Doing so, I'm left with my same term, 4n minus m. Combine my coefficients, pull out my like terms. I'm left with 4n minus m times 4m plus 7. Any questions on that one? Alright, so 21. I was given the following equation. I went ahead, I don't have subtraction, so I don't have to worry about pulling that negative in. So I went ahead and grouped them. In my first set, from 56 and 35, I can pull out a 7. I have at least one x in each term, so I can go ahead and pull that out as well. So my GCF is 7x between those terms. That leaves me with 8y minus 5. Looking at my second term, I can pull out a 2 from 16 and 10. I can also pull out 1r. I have 1r in each of these terms. So I'm left with 2r as my GCF. And I'm left with the same exact thing I got over here, 8y minus 5. Pull out my like terms, combine my coefficients. I should be left with 8y minus 5 times 7x plus 2r. Any questions on that one? These are still pretty much what we were doing yesterday, because we didn't have to move anything around or do anything to them. Everybody good on copying? So, 22, I was given an equation, went ahead and grouped them. Looking at my first group, I can pull out a 3x, right? I have 1x in each. Each one's divisible by 3. When I do that, I'm left with 7y plus 5. Then looking at my second term, I can pull out a 5 from each of my numbers. I can pull out exactly 1r, because 1r is in each term. Pull out my 5r, I'm left with my 7y plus 5. So pull out my like terms, group my coefficients. I can write this in either way because of the commutative property of multiplication. 3x plus 5r times 7y plus 5. Any questions on that one? You might have had it the other way, reverse. But either answer would suffice. Everybody good on 22? All right. 23. I was given this equation. I notice the only thing in common, I can't pull anything out of, so 5 is a prime number. Actually, no. So, yeah, 5 is a prime number. So the only things I can pull out of that are 1 and 5. Neither of those I can pull out a 4. Well, I can pull out a 1, but it leaves me with a 4. So the only thing I can pull out between these two terms is this a squared. In doing so, I'm left with 5z minus 4c. Looking at my second group, I have 15xz minus 12xc. I can pull out a 3 out of each of these numbers, and I can pull out an x out of each of these terms, because they each have one x. In doing so, I'm left with my 5z minus 4c. Pull out like terms, group my coefficients. You should have got 5z minus 4c times a squared plus 3x. Any questions on 23? Alright, so 24 was when things got a little dicey. The only reason it did so is because we had to reorder our factors into proper groups. So I could pull something out of each group, and I'm left with my proper terms. So I guess I've started with 4x, y plus 6 minus x minus 24y. Some things I notice about my terms is I have an x here and I have an x here. I have a y here and a y here. So I need to reorder them so when I pull out the common factors, I'm left with the same exact term. We were kind of given a method to confirm that we can factor yesterday, right? We were told that if we take this number, -1, and divide it by 4, it should equal this number divided by this one from the second group. Yeah, and so 6 goes into 24 4 times, right? 6, 12, 18, 24, negative. So this reduces to -1/4. So by reordering and then using the check that I stopped doing because it's just a check, but we can go ahead and check that we have this in the right order. So this checks out, and go ahead and factor my terms. So I get 4xy minus x plus -24y plus 6. In the first terms, the only thing in common is the x. So I can go ahead and pull that out. That's my GCF. I'm left with 4y minus 1. -24y plus 6. Between those, I can pull out a -6. That's my GCF. In doing so, I'm left with my matching term. 4y minus 1. Pull out my like terms, combine my coefficients, I get 4y minus 1 times x minus 6. Any questions about that one? All we did was reorder them. You can use this test, or you can kind of identify the pattern. Like, so I'm going to get a y minus 1 equals y minus 1 with some coefficients. The y, no y, no y. And I can also test them right here. Any questions on 24? We're just reordering the equation or formula. This doesn't have an equal sign, so it's not an equation, in order to factor it. So that's kind of a common theme in the rest of them. So we're given this equation, 21xy minus 12b squared plus 14xb minus 18by. So I need to reorder this. I can do so by grouping my terms. Now I can check by dividing this number by this number and this number by this number, and it'd be equivalent. The other thing I can notice is my pattern of terms. So I have b squared and b, but this term doesn't have a b, so in either one, I'm left with a b in my first term. And then I need a y in my second term for each one, because we need these to be matching, right? So after grouping, I pull out my GCF. For the first group, it's negative 6b. That leaves me with 2b plus 3y. In the next term, my GCF is 7x. That leaves me with 2b plus 3y. Pull out my like terms, combine my coefficients. I have 2b plus 3y, and then 7x minus 6b. I just rewrote that so my negative was subtracting. So I could rewrite this as 6b plus 7x, right? They're the same thing. Any questions on 25? Yes.
Could we use the primitive property to move each term? Like say 2b doesn't affect 3y, and 3y doesn't affect.
Yes. That's kind of what I was saying over here. So multiplication is commutative. So I could put this term first and this term second. Addition is also commutative. So I can put 3y first or 2b first. Yes. Sorry, what was that?
If you reorder your terms in multiple different ways, you get the same answer.
Yes. Yeah. You do not have to follow this process of reordering and everything, but you will end up with the same factors, or you should end up with the same factors, no matter how you reorder. Yeah, and then if same answer, meaning these are switched, 3y plus 2b. So if you put 3y plus 2b times 7x minus 6b, that's the same thing as this answer. So you're not wrong by doing that, you just wrote it a different way, because commutative property of addition, commutative property of multiplication. Any more questions about 25? Alright, 26, same kind of thing. the top was our original problem. I went ahead and reordered it in this fashion. That allowed me to pull out a 3m for my first term, right? Because 9 and 3, I can pull out a 3. I have 1m, 1m. I can pull that out. I'm left with 3z plus c. Then my second term, pull out the negative 4. This should be negative 4n. Negative 4n. I'm left with c plus 3z. Should be negative 4n too, right? Negative 4, yep. Sorry about that. So my GCF is negative 4n. And I'm left with c plus 3z. Does 3z plus c equal c plus 3z? Right? We just covered that. That's commutative property of addition. I can reorder that. So I pull out my like terms, because these are the same, they're just reordered. Combine my coefficients. I'm left with 3z plus c multiplied by 3m minus 4n. And that is 4n. I got to carry the n. Any questions about that one? Right?
So you can just change the order how it's
As long as you're not mixing the order of multiplication as long as what you're changing is either following multiplication and division or addition and subtraction. And you're not, so like I can't.
if you're multiplying something, you can't switch it out with addition subtraction.
Yeah, so like what I'm trying to say is, let's say I have 3z plus c and 3m minus 4n. So we kind of went over the proper ways to rewrite this, but I can't do some crazy thing like 3z minus 4n times 3m plus c, right? Those are completely different terms. So I can't reorder outside my multiplication. Like I can't reorder my addition outside my multiplication. But I can take this term and this term and I can flip them. Or I can take the terms inside my parentheses, this term and this term, and I can flip them.
I meant like initially, like how you change it.
Oh, sorry, yes. At the beginning of your equation, you can reorder that however you see fit into a way that you're to factor. Like you're talking up here? Yeah. So I reordered this because this is the same thing, right? Doesn't matter the order that my subtraction or addition happens, as long as I'm still subtracting and I'm still adding the same values. So real simple example, if I take 100 minus 5, that gives me 95, right? If I take minus 5 and I add 100, that still gives me 95. So it doesn't matter the order, as long as I'm still adding all the same values. It doesn't matter the order in which it happens. Any more questions about 26? Oh, all right. 27. We were given this problem. I went ahead and reordered it like this. in my first group, so I can pull out a 7x. I have 1x, each of these terms divisible by 7. That left me with 4y plus 5. My second term, I can only pull out a 5 between these. So I pull out my 5, that leaves me with 4y plus 5. Pull out my matching terms, combine my coefficients. We get 4y plus 5 times 7x plus 5. Any questions about that one? Again, I think it was like 24 through 28. It was just testing your ability to like reorder it, and for purposes of factoring.
What did you divide 35 by?
7. No, that means 5. Nope, you're good. Sorry about that, I was reading something. So number 28, again, we just reordered. We reordered it as 36u squared plus 30uv plus 30u plus 25b. I group and pull out my GCF between 36u squared and 30uv. I pull out a GCF as 6u. That leaves me with 6u plus 5b. Between 30u plus 25b, I can pull out a 5. That leaves me with my 6u plus 5b. Pull out my like terms, group my coefficients. Get 6u plus 5b times 6u plus 5. Can't say that this is 6u plus 5b squared because these are different terms. I don't have a b here. Any questions on 28? Nope. Alright, so for the rest of the time we're going to be looking at how to solve quadratic equations. So we were given some notes, so I'll give you those. So solutions to quadratic equation is where f of x, or we can also put the line of the graph, the line crosses the x-axis. So basically what this is saying is we're looking for our x-intercepts, where the function crosses the x-axis. There's some different names to these solutions. They're known as roots because once we start utilizing the quadratic formula, that will make a lot more sense. But they're known as roots. They're known as x-intercepts because we're looking at where the line crosses the x-axis. They're known as zeros because they're when our factors equal 0. That's where we get the 0 from. And then finally, tried and true, they're known as solutions. Solutions to our graph. So, we're just looking at a graph of a quadratic formula. I mean, any quadratic equation, right? We can directly point out our x-intercepts. Here in example 1, we can see this line right here is the x-axis, this line being the y-axis. We can see that we cross the x-axis at 2 points. X equals 2 and x equals -3. So because those are our x-intercepts of this equation, there are roots of the equation, there are zeros of the equation, there are solutions to the equation. So since we cross the x-axis at 2 and -3, those are all our solutions. You might also observe behavior like this, where the quadratic equation comes down and touches the x-axis. In this scenario, we only have one real solution. It's where the graph touches, because this graph will go down, actually hit 5. It will actually go down to the value of y equals 0 and hit 5 and then go back up. So when we see a graph of a quadratic like this, we know we have only one solution. We're only touching the x-axis once. Alright, so for this little tidbit in the middle, a factor has a variable minus a number, or plus a number, or plus or minus a number. To find our solution, we set that factor equal to 0. That's to find solutions. Then we solve that factor, right? All we have to do for this case is add our number over. So our solution becomes x equals that number. Now that's a little confusing, but we have a bunch of examples that we're going to go through. So, looking at this first one, we're given the factor x equals x minus 3. To find our solution, we set that factor equal to 0. So to solve this equation right here, all we do is add the 3 over. So our solution for that factor is 3, or x equals 3. So now for the second one, we were asked to work backwards. We were given x equals -6. Now it wants us to find the factor. How I did that? X equals -6. Add the 6 over. That looks terrible. X plus 6 equals 0, right? So if we were told that we have a solution of -6, we can work backwards and find that our factor was x plus 6. Alright, then we were asked to, we were given a factor, then we were asked to find the solution again. So you set it equal to 0, I subtract the 7, that gives me 2x equals -7, and then divide the whole thing by 2. That gives me my solution of x equals -7 over 2. Did everybody get how we got that? We just set the factor equal to 0 and then solve the equation. Right, for the next one, we're given a solution, and then we're asked to work backwards and find the factor. So, I know a solution means x equals that number. To get the 4 out of the denominator, I have to multiply the other side of the equation. So I get 4x equals 3. Then I need it to be equal to 0. So now I know I need to subtract this 3 over. So my factor becomes 4x minus 3. Any questions about that one? Yes, ma'am. You good? All right. So, last one. I'm given a factor of 2x. I set it equal to 0. To solve for this, I just divide 0 by 2, 0. Multiplied or divided by anything equals 0. So my solution is x equals 0 for the last one. Is everybody good on the note side of this? All right. And there is one part of your notes that doesn't actually cover why we can do this and get these equations. We can do this because of a property called the zero product property. So, what does the zero product property say other than that paragraph up there? It says if I multiply two things together and my answer equals 0, I know at least one of my parts of my equation has to also equal 0. Right? So if I multiply 100 by anything else other than 0, I won't get 0. And why is 0 important? We're looking for our x-intercepts. Equals x-intercept. And that happens at y is equal to 0. So this is why it's important and why we can say that if we set an equation equal to 0 and then solve for the individual parts, we can find the zeros of the equation. It's because of this property. If we end up with 0, we know that one of our factors, or one of the things we multiplied, has to equal 0. So that wasn't in your notes. That was just kind of a little tidbit of information. Let's go over example 3. On the next page, we're given y equals x squared plus 4x plus 3, right? So here's my equation. I need to start by factoring, right? So, 3, I have 1 and 3, those are the only factors. Y equals, both of these are addition, so I know both of my factors are positive. X plus 1, x plus 3. Based on what we just learned, we need to figure out where each of these values is equal to equal to 0. So to do that, we take each factor we take each factor and we set it equal to 0. Because if I do that, I can find out when this factor equals 0, and I can figure out when this factor is equal to 0. And based on our zero product property, that will let us know when y equals 0. Which is what we want, because we're looking for x-intercepts. So, x plus 1, real easy, negative 1, right? We just subtract the 1 over. X plus 3, subtract the 3 over. So, those are the two zeros of the equation. You know this because I can plug in negative 3 right here. I get negative 3 plus 3. I get 0. I get negative 3 plus 1. That equals negative 2. Doesn't matter though. So I already have a 0. Likewise, I can plug in negative 1. Negative 1 plus 1, 0. Negative 1 plus 3, 2. Doesn't matter though because I already have a 0 over here. Any questions about that? All we're doing when we solve quadratic equations by factoring is factoring and then setting each factor equal to 0. Everybody good on copying this down? That needs it? Alright. Example 4. We have y equals x squared plus 3x minus 28. So factors of negative 28 that add to 3. We do 7 and 4, right? And I have a positive 3, so I know my greater factor is going to be positive, and my least one is going to be negative. So 7 times negative 4, I get my negative 28. 7 minus 4, I get my positive 3. So this becomes y equals x plus 7, x minus 4. So I'm solving for when y is equal to 0. So I need to set each of my factors equal to 0. And then solve for each. X equals negative 7, right? Let's subtract the 7 over. 0 minus 7, negative 7. X equals 4. So those are my two zeros of this equation. Any questions about that? Yes, sorry. There won't be an instance where one of your factors, you can't get it to equal to 0 because you're the one setting the factor equal to 0. There are quadratics though that don't have real solutions. They have what are called imaginary solutions, and we don't have to worry about that. Essentially, all that means is they don't cross the x-axis at any point. But you won't be solving those from grouping. You won't ever be given a grouping problem or factoring by grouping problem and where you have to find an imaginary solution. That won't happen. So, example 5. Y equals x squared minus 4x plus 4. Alright, we're really good at factoring now, right? So, we can just say x minus 2, x minus 2, right? Is a perfect square trinomial. Negative 2 times negative 2 equals 4. Negative 2 plus negative 2 equals negative 4. Now I want to know when that equals 0. So these, I'm going to get the same x value, right? Add the 2 over, x equals 2, x equals 2. It doesn't mean that I have two solutions at x equals 2. That just means I have one solution at x equals 2. So you don't have to write, if you factor, and it's a perfect square trinomial, which is what this is, you get the same factors, or same number for each factor. You know you don't have to list both, because you only have one. What I meant to do was show you all that. So, I have my graph of my function x squared minus 4x plus 4. We can see it does that behavior that we were kind of talking about before, where the graph only touches the x value. So we only have one solution for this graph. This is what we got. X equals 2. Everybody good on example 5? Alright, so example 6, we're starting to get a little tricky. 0 equals 25x squared minus 16. What do I know about 25 and 16? Exactly. If I take the square root of either of those values, I get a whole number. Open the board, yep. Right? So I have two numbers that are squared and they're subtracted from each other. What condition does that, what formula can we use now that we've identified that? Remember this one? A squared minus b squared equals a plus b, a minus b. That's our difference of squares formula, right? So let me rewrite this as 0. So I have 5x, so I have 25x squared. I know the square root of 25 is 5, and then the square root of x squared is x. So 5x, that whole value squared. If I undo that, I have 5 squared, I get 25. X squared, I get x squared. 25x squared. Then I get 4 squared. It's coming from the square root of 16 equals 4. 4 squared equals 16. So now I can associate those terms with my a and my b. My a is going to equal 5x. My b will equal 4. So we were given this side of the difference of squares formula. Now I just need to write out this side. I get 0, because it's still an equation. I need to bring that down. My a, which is 5x, plus my b, which is 4. a minus b. So a, 5x, minus my 4. I get my two factors. Any questions about that? We just had to remember that difference of squares formula. A squared minus b squared equals a plus b times a minus b. Difference of squares. But I'm not done yet, right? Because I need to find where these values equal 0. So I just set each one equal to 0. Right? Subtract the negative 4, or subtract the 4. I need to, over in this factor, I need to add a 4. So I get 5x equals negative 4. For this one, we have 5x equals 4. For my second factor. Now I need to divide the 5. In doing so, I get x equals negative 4/5, right? I had negative 4. I divided 5. I get negative 4/5. Likewise over here, 4 divided by 5, I get 4/5. So I know I have zeros or roots or solutions or x-intercepts at those values. Any questions about that one? Relatively easy once we remember the DOS, the difference of squares formula, and we recognize that this was the difference of squares. The squares being 5x and 4. Give everyone some time to write that down. Needed. Alright, so moving on to example 7. Zero equals 2x squared plus 6x minus 36. Anyone, what's the first thing I should do here? You're saying slide and divide? Okay, so yes, we need to pull out the GCF in order to avoid the fact that we might have to slide and divide here. But if I pull out this GCF first, I don't have to worry about sliding and dividing. So only 0, so I have an equation. I have a GCF of 2 between all my numbers here, right? I can pull out a 2 from 2, I can pull out a 2 from 6, I can pull out a 2 from 36, negative 36. So I'm left with x squared plus 3x minus 13. So now I need factors of 13 that equal 3. Wait. Yeah, this should be 18. Sorry about that. Yeah, 36 divided by 2 is 18, not 13. So this needs to be 18 as well. So, factors of 18 that add up to factors of negative 8 or 18 are, we have 1 and 18, we have 2 and 9, we have 3 and 6. Alright? Now I need it to be negative 18, but my b value is positive. So I know my greater factor is positive. My least factor is negative. 6 times negative 3, I get negative 18. 6 minus 3, I get 3. So I have my 2 out front. I have x minus 3, x plus 6. Alright. What do I do with this 2? Right? Because I'm at the point where I need to start setting these equal to each other. So this 2 is actually a factor. So I need to set it to equal to 0. However, we know that 2 does not equal 0. This is one we know we have an imaginary solution, but we don't care about that. So for this one, you just essentially drop the 2, but you set each factor equal to 0. So we're setting 2 equal to 0. We're setting x minus 3 equal to 0. We're setting x plus 6 equal to 0. We just know that this one is non-existent in our realm because 2 does not equal 0. So I can completely forget about that 2 for now, or actually for the rest of the problem. Add the 3 over, x equals 3. Subtract the 6, x equals negative 6. Those are my 2 solutions for this problem. So I plug 3 into here, I get 0, makes that whole thing 0, makes that true. Plug negative 6 into here, I get 0, makes this whole side of the equation 0, makes 0 equal to 0. We do set the 2 equal to 0, but we don't get a solution from that because 2 does not equal 0. Any questions on that? All I did was set each factor equal to 0. That's where this 2 went. I set it equal to 0. I determined that 2 does not equal 0. We all know that. I moved on from it. I got my actual x-intercepts, my real x-intercepts. Any questions on example 7? All right. Example 8. 3x squared equals 8 minus 10x. So, I know I need a 0, and I don't have one. So I can get one. I don't want to make this negative. That feels like a lot of work for me. So I'm going to add the 10x over. So add 10x and subtract 8 from each side. So I don't want my a term to be negative. I'm not a fan of that. If you subtract that over, though, you're not wrong. You'll end up getting the same zeros. I just don't like my a terms to be negative. So I get my 3x squared. I'm adding my 10x, so plus 10x. I'm subtracting my 8. I'm doing that same thing on this side of the equation. I subtract 8, I add 10x. It leaves me with 0. Any questions about that? I'm just getting one side of my equation equal to 0. Alright? So, is there a GCF I can pull out between 3, 10, and 8? No. So I'm going to have to slide this into the negative 8, right? Bring it over here, 3. That gives me x squared plus 10x minus 24 is equal to 0. We're sliding and dividing right now. So I need two values, factors of 24 that I can equal to negative or positive 10. So I get 12 and negative 2, right? Negative 2 times 12, I get negative 24. 12 minus 2, I get my 10. So x plus 12, x minus 2 equals 0. So now I gotta divide out my 3 that I slid in, right? So 12 over 3, 2 over 3. I get x plus 4. 3 does not go into 2, so I need to slide this one back up. I was able to evaluate that one to 4, right? Wasn't able to do anything with this denominator, so I need to slide it back to the front. Minus 2 equals 0. Does everybody have the notes up to this point? So I'm going to go ahead and jump to another piece of paper. We're just sliding and dividing over. We found our two factors. We divided out what we slid over, and we're left with our two factors. So x plus 4, 3x minus 2 equals 0. This is where I'm at right now. So now I need to solve for my solutions. Set each factor to 0. X plus 4. Subtract the 4 over. I get x equals negative 4. So I have one solution. 3x plus 2, or minus 2. Add the 2 over. We get 3x equals 2. Now I need to isolate the x. I do so by dividing by 3 on both sides of the equation. We get x equals 2/3. These 3's cancel. And this was my second solution. Any questions about, what was that? Example 8. That's not really going to work. Alright, go ahead and go to 9. Were you still writing stuff? You good? Okay. Example 9. Alright, we are given a problem, our equation. Alright, I'm going to do the same thing. I'm going to set one side of my equation equal to 0. I know I have an x squared. That makes this my a term. I don't want that to be negative. So I'm going to subtract these values over. Negative 28x and 24. Minus 28x minus 24. So I get 12x squared minus 28x minus 24. That equals 0. Everybody see how I got that? Just manipulating equations. Alright. Now, I notice that I have a GCF between all these numbers, right? Everybody know the GCF in all these numbers? Exactly. Yeah, I can pull out. Wait, did someone say 6? 6? Yeah, I can't do 6. Because 6 times 4 is 24. And 6 times 5 is 30. So I can't reach 28 with 6. But yes, I got 4 as well. So I'm going to go ahead and do that. Pull out my 4 from each one of my terms. 3x squared minus 7x minus 6. I'm still dealing with an equation. It's equal to 0. Alright, I can't get rid of this 3 because it won't go into 7. 7's a prime number, so 1 and 7 are the only things I could pull out of 7. So I know I need to slide this in. Times 3. I still have my 4 out front. I have x squared minus 7x minus 18. Alright, values of 18. Yeah, so we got 118, and we got 2 and 9. And we also got 3 and 6. But the 2 and 9 is what I can manipulate to get negative 7, right? So if I set the negative 9 to, if I set the 9 to negative, I set the 2 to positive, negative 9 times 2, I get negative 18. Negative 9, sorry, I want to make sure we're in the equation. Negative 9 plus 2, I get my negative 7. So these are the factors I need to use. So rewrite this as my two factors, x plus 2, x minus 9. But we slid this 3 in, right? So now we got to divide it back out. We're still dealing with an equation. So we have 4x. Sorry. So 3 does not go into 2. So I need to slide this back up. So this becomes 3x. 3 does go into 9. How many times? 3 times. So I don't have to slide that forward. So I get my 3x plus 2. I get my x minus 3. So I divided out what I slid into those terms. And that is all equal to 0. So I said each one of my factors equal to 0. 4 equals 0. 3x plus 2 equals 0. And x minus 3 is equal to 0. Right? I know 4 does not equal 0. I can go ahead and forget about that. Subtract the 2 over, right? So I need to start getting x by itself. 3x equals negative 2. Divide by 3 on either side. Get x equals negative 2/3. That's my first solution. Right here, real easy. Just add the 3 over. X equals 3. Now I have my second solution. Any questions on example 9? Does anyone need me to go back so they can fill out some stuff? Alright, so the final example, and then you'll have the rest of the block yourself, is example 10. You're given 4x squared equals negative 10x. Alright, so I want something equal to 0, right? That's always going to be my starting point. I need some kind of quadratic equation meaning I have an x squared term, and quadratic means my highest term is going to be x squared. I won't have an x cubed or anything. X squared is my highest term, set to 0. So I'm going to do that by adding the 10x over. So 4x plus 10x equals 0. I did that by adding this 10x to either side. Alright? What's the GCF between 4 and 10? Alright? Now I have an x squared and an x, right? How many x's can I pull out of each of these terms? Exactly. In doing so, I'm left with 2x plus 5, right? If I was to distribute that 2x back in, I get 4x squared plus 10x. 4x squared, 10x. Can I factor this anymore? No. So now I have my two factors. Yes, they're not in your normal 3x plus 2x minus 3 fashion, but I still have two factors that I've made here. So I can set each one equal to 0. So 0 divided by 2, to isolate the x, I get 0. Over here, subtract the 5, I get 2x equals negative 5. Divide the 2, get x equals negative 5 halves. Any questions on number 10? This one actually wasn't even really factoring by grouping, right? We just pulled out the GCF. Alright. So, for the rest of the class and homework, but we'll go over it tomorrow. Let's do the odd problems from the next worksheet. So 1, 3, 5, 6, 7, 9, 11, and 13. So the odds from this one. And then every other problem from this one. So starting with A, we have A, C, E, G, I, K, and M. So every other one. A, C, E, G, I, K, M. And then we'll be done with this. I'll actually be working on something that's not a packet. So, but we'll get into that tomorrow. Any questions about what we did today? Oh, yes, sorry. It was supposed to be today, and I was told today it was supposed to be today. So obviously it's not going to be today. And then, so after talking with the plumber, this is what we're going to be doing tomorrow, is a test review. And I'll go ahead and put them up at the front if you want to grab one and look over it. we're factoring, right? All of these problems, we're just factoring. Here, these top ones, we're just factoring again. Down here, we're solving, which is what we did today. So we're factoring and then setting it equal to 0. That's what we're doing here for these three as well. Here, you're given the solutions and we're asked to work backwards. We'll look at this one tomorrow. Working backwards is always interesting. Then, for this one, we're just given a value that we need to plug into the equation and evaluate. So we're given b equals -1, we plug in -1, we evaluate. We gotta remember, I believe this was you guys' unit 1, talking about inequalities and stuff. Next one, we just plug in the value. And again, we're just plugging in the value. Then we have a little refresher where we're talking about equations. We have some inequalities. Sorry, we have absolute values. That's not, I don't know what's wrong with it. Those are absolute values, not inequalities. This is an equation, not an inequality. Absolute value. Absolute value, not inequality. I don't know why I said that. Over here, though, we are asked to solve an inequality. So I believe that's stuff from either the previous unit or the unit before that. We have more solving inequalities. Solving inequalities. We'll look at this. We're just analyzing graphs. Circle all the intervals where the function's increasing, right? So where the slope's positive. So we'll -2 to 0, and then 0 to infinity, right? So then we're just analyzing graphs as x goes to -infinity. Where does f of x go, right? So -infinity is, as x goes to -infinity, we're going backwards. The line has an asymptote here at 4, so f of x goes to 4. We'll go into all of this in more detail, but this is the test review. And ultimately, the test we would have, today's Wednesday, we'd have test review tomorrow and test on Friday. I'm going to be here, I should be able to be here Monday, so we'll probably have the test on Monday. That'll give us the entire weekend to look over this. The new stuff on the test is just the factoring and the solving quadratics with factoring. And then a lot of this stuff looks like review from when I was subbing in other classes. So we'll go over it. Domain, our minimum and maximum x values. Our range, our minimum and maximum y values. We're given an inequality with an absolute value. We're asked to graph it. And here, what we did today, identify the roots, or the x-intercepts, or the zeros, or the solutions. Where does this line cross the x-axis? Right here, we're given a system of equations. This was kind of hard to read, but it's still, we're focusing on the solutions, or the x-intercepts. Where do these graphs cross the x-intercept? And then we're told we have f of x, and f of x has the following three factors. Then we're asked to choose all the statements that are true regarding. So we'll have to, like right here, is negative 1/2 a solution to f of x? Well, from right here, we add 1, divide by 2, but it's not negative, right? Because we're adding 1 and then dividing by 2. So no, negative 1/2 is not a solution. So the new content that will be on the test that is hopefully Monday will be factoring. If you are comfortable with factoring, you should be comfortable with solving quadratic equations by factoring. So all we're doing is setting the factor equal to 0. Yes, sir. Yes, it should. And I've been dealing with like AFCA, my block 2 and 3 stuff, and I just got their access to Synergy, and we're dealing with grade stuff. So basically, probably what's going to be on your guys' marking period 1 grades is all the stuff that Ms. Patton was able to actually already grade. Because I don't have access, my other assistant teachers that are helping me out don't have access to Ms. Patton's Algebra 2 stuff. So there'll be no updates until someone can go in there and do that. So again, for homework, we just have the odd problems of this page, and then every other problem of this page. If you have questions, go ahead and keep them for tomorrow, because I actually won't go over every question. That way we're guaranteed to have enough time to go over the test review. So do this. If you have questions about a certain problem, make sure to mark it, because that's what we're going to go over. Do every other problem on here. Make sure to mark it. I don't plan on going over each one of these in detail, because I want for us to get into this in detail. Any other questions?